Hello everyone, and welcome to another episode of our Hackolade tutorial. Today we're going to be talking about something that is quite important and quite an undertaking actually, because it's going to take us a little bit of time to get through everything. We're going to be talking about how you can use Hackolade and the Hackolade Studio for versioning and collaborating on your data models. This is a really important part of our story. We call it one of our pillars because we believe that it's going to be essential for us to tie in to the modern ways of developing software if we want to keep the data modeling industry in general as relevant as it ever has been, right? We all know that, in agile software development, we have this infinity loop, right? Where wherever you are, there's always something happening to the code base, to the software project that we're working on. We're always planning, coding, building, testing, releasing, deploying, operating, and monitoring what is happening to our software. It's a continuous process that, for as long as the business application is relevant and adding value to the processes, this is going to continue forever. Now, what Hackolade has been advocating is that this should also apply to the data models that are used in this lifecycle, right? So whenever you have this infinity loop happening for your software, at the same time, you should be specifying your data model, designing it, generating the schemas for it, cataloging it, integrating and migrating it, publishing it, using it, evaluating it, and starting all over again, right? So the DevOps infinity loop should also be accompanied by a data modeling lifecycle that is also an infinity loop. We think this is really important, right? We really think that data modeling in an agile and DevOps context should still be happening. For some time, people have been saying that, with all these agile technologies, with all these NoSQL technologies, the data is the model. We don't really need to be thinking through our data models as much. Well, we disagree. We think that this is still not an optional thing to do. It should still be a mandatory thing to do, and it will greatly help software quality, the software costs, the delivery time frame, and everything that goes with a good quality software delivery in an agile enterprise. We call this Metadata-as-Code. We believe that if we treat our metadata just the way we treat our code, with the same care, with the same agility, with the same speed, tune it in to the business lifecycle that we are trying to accommodate, that is actually going to prove and deliver the relevance that we need for the data models in everyday practice. So we want to treat the metadata as code, and in the Hackolade Studio, we have built a number of tools that allow you to do this really, really easily. And all of these mechanisms are built on Git, right? Git is something that many technical people will probably already be familiar with. Many less technical people may not have ever touched it and may even be a little bit afraid of it. What is Git? Well, Git is something that was originally developed by Linus Torvalds for the Linux software development community, right? So it's a version control system, but it was geared to that community, which means that it was inherently distributed. Right, so Git is a version control system that is not relying on centralized control and centralized copies of the latest software version. No, on the contrary, it's actually depending on a distributed version of that software, so that all of the different contributors to the Linux ecosystem could work in parallel and could help each other and collaborate without too much reliance on that centralized system. So this is very different from traditional central version control systems made for agile teams, and conspicuously and consciously not dependent on so-called locking systems. Right, so in a centralized version control system, people always dependent on the fact that someone would be locking the version of the code base that people will be working on, while other people just basically had to wait. Right, so that mechanism obviously is a kind of like a shotgun approach. Okay, we lock everything, so that is probably going to be safe. Right? Git is much smarter. A distributed version control system is much smarter and is much more granularly organized, so that people can constantly work on their part of the code base without actually impacting someone else. That means that there's a completely different way of working, accompanied by a completely different vocabulary. Right? So we will be talking about push and pull requests. And these are very much new concepts for many different people and many data modelers specifically. Originally, Git was also something that was actually based on a command line interface only, and to be honest, that was kind of daunting for many people, not just data modelers. So in Hackolade Studio, we're going to try and make this easier to use so that everyone can leverage Git, right? And that the decentralized distributed version control system that it offers will actually contribute to a much more successful way of doing data modeling. What we mean with that is that, first of all, thanks to Hackolade Studio's JSON-based file storage, it's actually really easy for us to use Git for the task of managing versions and collaborating on these JSON documents that are underpinning our data models, right? On top of that, the entire approach, right, where people are constantly working together and constantly working in parallel on their part of the task is very much in tune with our love for agile software development, domain-driven design, and domain-driven data modeling, and NoSQL data storage formats. We think that this really plays well with our vision. We want to reconcile business and IT through a shared understanding of the meaning and the context of data. And we're going to do that by making it easy for everyone to interact with Git, so that business can use the same tool as IT, so that business and IT can leverage the same single source of truth. What does that mean? Well, it basically means that every time you're working on a data model and that you're generating schema or that you're working on application code, all of these resources, all of these artifacts are going to be uploaded to the Git repository that is shared by everyone. The wonderful thing about Git also, not just the fact that it's a decentralized distributed version control system, is that it's so well integrated with lots and lots of very powerful automation tools. Everyone's been talking about developer operations, DevOps, right? Well, DevOps, one of the key things that they do is that they operate with pipelines. They make sure that every time something needs to get deployed into production, this is not someone manually pushing a few buttons or typing a few commands. No, there's an entire pipeline that automates this. And therefore, if our modeling artifacts are also present in the same Git repos, that means that these pipelines can also leverage those models. Right? They can also integrate things like automatic documentation generation. Right? All of that is now all of a sudden possible thanks to the fact that the models actually reside in Git. So what are you going to do? Well, all of us are going to be working in our local repos, right? The clones of the Git repository. We are going to store our models in these repos, and time and time again, we're going to be uploading those models to the centralized remote copy of the Git repository, so that all of a sudden we can integrate this super easily through potentially our command line interface, the Hackolade command line interface, to, for example, generate schemas, right? DDL files, OS files, JSON schema files, Avro schema, whatever it might be, right? It's going to be automatically generated through the command line interface, and of course, also stored inside the Git repo, so that we can then send this to all kinds of consumers. For example, the documentation that we generate can be automatically distributed to whoever wants to read them. The entire orchestration that we know from our DevOps code generation processes is now also going to be underpinning our metadata pipelines, right? So that the technical data structures and the business-facing data dictionaries will always be in sync with the latest and greatest version of what we are delivering to our business users. So that means that Git is going to be the basis for all collaboration, all version control, all change tracking, and all reviews that are currently being performed on our data models. Now, in the rest of this tutorial, we are going to be showing you in detail how this can work, right? And we're going to be doing this using 4 different scenarios, right? Because there's quite a few ways that you can organize this. And so now what I'm going to do is I'm going to tackle each of these scenarios, from very simple to quite complex in a sequence, and then I'll come back to you and we can wrap up this tutorial. All right, so let's get going. So how are we going to do this? Well, what I've done is I've created a specific GitHub repo that will allow you to quickly understand how this type of environment might work, However, there's a couple of things that are a little bit specific about it, and I'll try to explain those. But the repo is this one over here. It's called Hackolade Git Test Repo, right? There's a README here, and actually in the README, we're going to be following some of the instructions that you find here with all the different scenarios. We're going to be walking through that as we go along here. The important thing that you should realize is that in this repo, we actually are going to store our data models, but we're going to store them in two separate clones on my local machine. And this is important, right? So we have the remote, right, which is the centralized storage of our modeling information and potentially also our code. And what I have created is two separate clones, clone 1 and clone 2, on my local machine to simulate how we could collaborate with one another. Right, so right now these clones are going to be used by the same user, right? This in both cases is going to be me, right? But what you will see is that it doesn't really matter which user is actually using those clones. It is all about what happens in those clones and how the actions that we take inside those clones get reconciled and get merged together inside the centralized remote copy. Right, so let me show you this, right? So I've got my GitHub test repo right here, and inside it I have created two clones, clone 1 and clone 2. And of course, right now they are identical. They are exactly the same. They've got the same README file. They've got the same basic model in here. They've got some illustrations in there, right? And it's exactly the same because both clones have just been pulled from the remote so that they are identical. That process is actually facilitated inside Hackolade, right? In the Git interface of Hackolade, you will see that I have a clone 1 and clone 2 repository in which I can also have separate branches. Right? So in every clone, I can have a branch and then work in that branch and then push that branch to the remote so that it can be merged into the main branch. Right, so we've got that here in Hackolade as well, and we can work with that. And now that we've done that, we are ready to start actually collaborating, and we will start doing that in a series of different scenarios.